Okay, here we are. This is the Math B 2018 Fall Finals Study Guide and Notes. This video is on page 1. I'm just going to march through the different parts that come in the study guide, and you'll have them as reference. So the first part is about rate and unit rates. So the direction reads, and we want to write rates as described. That means when you're told to write a rate, you have to note if they give you certain values, use the values they give you. When they tell you to simplify, then you simplify. But if they don't give it to you, just write what you're given. You drive 8 hours, you drive for 8 hours and cover 480 miles. Write this rate in miles per hour. So this is telling me how I need to write it. I need to write it in miles per hour. So in this case, I have 480 miles in 8 hours. And because it's a rate, rates must include units. So 480 miles in 8 hours. There is our answer. You drive 8 hours and cover 480 miles. Find the unit rate. So the unit rate, remember a unit rate in miles per hour. So there's our hours again, in miles. So remember a unit rate has a denominator of 1. So I don't want to know how many miles were done in 8 hours. I want to know how many miles were covered in 1 hour. So again, the rate is in miles per hour. I have 480 miles in 8 hours. I can divide both of these by 8 because I can see 48 in there. So I'm going to divide the top by 8, divide the bottom by 8. And on the bottom I have my 1. That's good. 480 divided by 8. I can think of it as 48 divided by 8. 48 divided by 8 is 6. So 480 divided by 8 is 60. 60 what? 60 miles in 1 hour. There is our result. Moving on to complex fractions. We want to remember that a fraction is a division problem. This is great because it helps us do things with fractions. And oftentimes it's helpful to remember to reduce before computing. Reduce before computing. So let's simplify these. So I have 36 over 42 all over or divided by 6 over 28. So my problem here is I'd have to simplify is 36 over 42 divided by 6 over 28. We should probably remember that in any fraction when you have a numerator and a denominator, this is a division problem, and it is specifically numerator divided by denominator. Or if we were to write it in the long division format, it would be the numerator divided by the denominator, whatever those values are. So when I have one fraction divided by another fraction, we always applied keep, change, flip. That's our little how we remembered the process. That means I have to keep this fraction the same. I'm going to change the division to multiplication, and I'm going to give the reciprocal, or flip, the other fraction. Keep, change, flip. And now I have this problem, 36 over 42 times 28 over 6. Now that gets kind of large. So I want to remember this helpful hint. Can I reduce anything? Well, yeah, I look at this and I see 36 and 42. Both of those can be divided by 6. So I'm going to divide this by 6, and I'll divide this by 6. And I see that 28 and 6 are both even. I can divide both of these by 2. So let's do that. So 36 divided by 6 is 6. 42 divided by 6 is 7. The multiplication stays the same. 28 divided by 2, that's half of 28, or 14. 6 divided by 2 is 3. Now that's a much more manageable problem there. In fact, I noticed that 7 is a factor of 14. And I see that these two go into each other as well. So I'm going to rewrite this and try to make it even more simple. So 6 is the same as 2, that means multiply, times 3. And I'm going to multiply that by 14, but 14 is 2 times 7. So the 6, that's my 6. 7 I'm going to bring over. Here I'm going to bring the 3 over. And I see, hey, I have some things that are the same top and bottom. So this 3 will cancel with this 3. And this 7 will cancel with this 7. And the only thing I have left then is 2 times 2. So I have 2 times 2. 2 times 2, or 4. So this all broke down and was 4. Here's one more example. See, I'll draw a line here and try and separate the work to keep the two from each other. So I have 15 over 27 divided by 20 over 12. All right. Numerator divided by denominator. And I'm going to do keep, change, flip. 15 over 27 times 12 over 20. And again, I can simplify. So I'm going to simplify first. Because if I didn't, this mess becomes, if I just multiply it straight across, 15 times 12 is 180. So I would have to be stuck simplifying this. 180 over 540. Let's simplify first. So 15 and 27 both have 3 as a factor. So we'll divide top and bottom by 3. And 12 and 20 both have 4 as a factor. So I'm going to write this revised problem right here. So 15 divided by 3 is 5. 27 divided by 3 is 9. And that's going to be multiplied by this. So 12 divided by 4 is 3. And 20 divided by 4 is 5. Ooh, look at that. I have some things I can cancel out. The 5s will cancel out. All right, so those go. And I'm left with 3 over 9, which simplify, divide top and bottom by 3. Final answer, 1/3. Moving on. Proportions and cross product. This is a process that students come 7th grade, they need to become much more familiar with this. If it's possible, remember to reduce before you compute. Reduce before computing. So, solve using the cross product. So it's telling me I have a very specific method I must use, and that's the cross product. Cross product, remember, is those two numbers multiplied together equal these two numbers multiplied together. And the reason we can get away with this, remember, is if we just look at a pair of equivalent fractions, say 2/4, which is a half, and 5/10. When we do the cross product of these two, you'll notice 2 times 10 is 20, and 4 times 5 is 20. So 20 equals 20. That's why the cross product works as a method. So I have 30x. So if I were to do this, I would have 30x is equal to 9 times 45. 9 times 45, what is 9 times 45? 9 times 40 is 360. 360 plus 9 times 5 is 45, which would be 405. And I have to divide both sides by 30 to solve this, because I got to get the x by itself. And this is doable, but let's reduce first. Let's do that. Because I noticed that both 30 and 45, I can divide both of them by 5, and that would give me 6 over 9. But then I can reduce 6 over 9, would be 2/3. I also notice that both of these are factors of, or multiples of 15. So if I divide top and bottom by 15, this becomes 2 over 3 is equal to 9 over x. That's a little simpler to do. If they're 30 over 45, if we didn't quite see that, let's do it one more time here. I can divide both by 5. 30 divided by 5 is 6. 45 divided by 5 is 9. And then I could divide both of these by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So now let's do the cross product. So I have 2x is equal to 3 times 9, 27. I'm going to have to divide both sides by 2. Remember, I've got an equation here. See my equal signs staying nice and lined up? That keeps my left side separated from my right side. 2 divided by 2 is 1, and 1 times x is x. So what's half of 27? Well, half of 26 is 13, so then I have 1 left over, so this will be 13 and a half. Or if you want to see the decimal, 13 and 5/10 if we were to actually plug it into a calculator. I'm looking at this again, and hey, look, I can simplify that. I'm going to simplify first. So I can divide top and bottom by 2, and this becomes 1/10 equals x over 29. So cross product. 10x is equal to 29. And the convenient thing about this, I like this, because when I divide by 10, I set up something that's, when I divide by 10, I'm just moving the decimal as many zeros as I have in my denominator. So 10 divided by 10 is 1, and 1 times x is x. So this is 29 divided by 10. And when I divide by 10, I move the decimal. So remember, here's 29. When there's no decimal written, we understand that it's to the far right. And I'm dividing by 10. That means I'm going to move 1 place value to the left. So it's going to look like this. So the decimal point moves 1 to the left. So x is 2 and 9/10. There's my answer. I should box this answer too, shouldn't I? Make it more readable. Okay, here's another cross product problem, but it's in a situation. So I have to read carefully and pull out the parts. If you can watch 8 cars in 24 minutes, ooh, that sounds like a rate, doesn't it? 8 cars in 24 minutes. You know, cars per minute. Then how many cars, so cars was yellow, how many cars? My answer is going to be a number of cars can be washed in 90 minutes. And the directions say, set up a cross product and use labels to answer this question. So let's set up the cross product. I have cars, so many cars per minute being washed in this case. What they give me is 8 cars in 24 minutes. And they're asking me how many cars. Well, cars are on top in 90 minutes. Well, minutes are on the bottom. And they're asking how many cars. I don't know. That is going to be my variable. I see that I can simplify this. I can divide top and bottom by 8. By 8. 8 divided by 8 is 1. 24 divided by 8 is 3. So now I have something that looks like this. So you might see that the answer 3 times 30 was 90. So if I did the same with here, 1 times 30 would be 30. But let's go ahead and do the cross product just to double check. 3 times x is 3x, and that's going to be equal to 1 times 90 is 90. So now I'm going to divide both sides by 3 because I want to get x by itself, and x equals 30. Okay, I've got this answer. That's great. But in the final, I'll probably ask you to write the answer in a sentence. So what does this mean? It means they can wash 30 cars in 90 minutes at a rate of 8 cars in 24 minutes. At a rate of 8 cars in 24 minutes. Notice this language here. It's very much our proportional reasoning. We're using one relationship, 8 over 24, to answer a question about another relationship. That's a definition we've used in class over and over and over again. Proportional thinking uses one relationship to answer a question about another relationship. Next question, we're done with this first page. Is the relationship proportional? If yes, then determine the constant of variation. Ooh, there's that constant of variation. So in order to check if a relationship is proportional, the ratio of the quantities will be the same. So I need to set up, I'm going to let hours worked, I'm going to let that be my X, and let my dollars earned Y. And usually that's typical. The amount of money I earn depends on how many hours I work. So I need to check up this ratio, the ratio of Y to X, that is dollars to hours. So in the first one, I'm going to have 60 over 5. 60 over 5 is 12. And then I have 96 over 8. I have to check that. 96 divided by 8. Well, 8 times 12 is 96, so this is 12. And I have 132 over 11. 132 divided by 11 is 12, or 12 times 11 is 132. So the ratio is the same. So, whoops, wait for the bell. Because the ratio is the same, because the ratios are equal, the relationship is proportional. We can also see it this way. When we look at the rate of change between these things, there's a rate of change of 96 minus 60 is 36. And here's a rate of change, 5 to 8 is 3. 36 divided by 3. This is the change in Y, and this is the change in X. Right? The rate of change. 36 divided by 3, 12. So in this case specifically, and this 12 is my constant of variation. My constant of variation is 12. This is the end of page 1.